Right, we'll go back from lunch from my behalf as well. I'll first go through a bit what Rolls-Royce does. So this is a bit of the content which I'll be covering over the next 40 minutes or so. So we start off with Rolls-Royce, what we do, and what's remote and autonomous operations. Then we'll go to roadmaps, have a look at those, what's the current state in technology today, and then go a bit back in time into how UX came into our organization, how it started to influence what we do, and then a bit about the future on what we're currently working on and what we'll be developing over the next 5 to 10 years' time. So as a first disappointment, we are not working with cars, so only the brand is the same. So Rolls-Royce brand is leased to BMW for the car manufacturing, so we are not involved in that part of the business. Our major business area is aerospace. Myself, I'm representing marine. Then also we have power systems and nuclear as well. But aerospace is the biggest one, and then marine is the second one, and then the other two ones are different sizes. And in this region, you may know us from MTU engines, so we also own that brand as well. Then marine itself, marine is divided into different areas. So we are working on commercial marine, but we also work on naval marines, and approximately 70 navies around the world use our systems in their fleet. And then we have hundreds and hundreds of customers in commercial marine using our different equipment. And in commercial marine, we have everything from ship design to all the equipment on board, but nothing which has something to do with the comfort of people on board or the passengers on board. But all from the equipment and machinery side is that what we have. Mooring system, engines, propulsion systems, control systems and everything. So it's in that sense, it's natural that we are now moving for autonomous shipping where the people are taking it out of the seagoing equation at least. Then the department which I'm representing is called Ship Intelligence. We are a fairly new organization part. We started off in 2015. And our aim is to make vessels smarter, and basically our business is based on data, and we are building our business model on reusing data in different manners. We have 3 different areas in our organization. One side is looking at health management, so equipment health monitoring, how different systems behave on board, and monitor those. Then we have optimization and decision support systems. Those are mainly, for example, energy management systems, where we look at how batteries are used on board and handle the balance of energy. And also all vessels are required to report their pollution readings and NOx values, so we have a system that is automatically gathering all that data and providing reports on that. And then I'm heading our business for remote and autonomous operations, where we do develop different solutions in that field. Mainly the first one is situational awareness. So when we are taking the bridge off the vessel, we still need to see in the same manner, and we need to detect what's around us. So we are developing solutions for that. Kind of similar things what automotive industry is doing with the self-driving cars, same technologies. The major difference is that cars need to see 200 meters, we need to see 100 kilometers, so there's small change in ranges. But technology is pretty much the same what we use. Then we are also having features like auto parking, where a vessel can do all voyage operations on its own. And then the last one is the vessels themselves. So we have different vessels for remote and autonomous operations. And I have a few slides on those coming up as well. So that's the short introduction to Rolls-Royce and what we do and our ship intelligence business. But then going into a bit on the remote and autonomous side. So here you can see our timeline of operating, and our aim has been since the beginning of 2015 when we started that by 2020 we will be having the first commercial vessel remotely controlled in commercial use. And that's the aim and the target we are working towards. And then gradually from there, with different steps, we'll be going to full ocean-going ships. Currently there are different things that are blocking this development. Technology is more or less in place, but the major blockers today are regulatory rules. So you can do it, for example, autonomous shipping you can do within one flag state area, but you cannot go from one flag state to international waters because of the regulations. And it's pretty much the same situation as with cars. You cannot take an autonomous car or self-driving car and take it from Finland to Spain and drive it all the way autonomously because of the regulations. But you can get from one country, you can get the regulations in such exemptions that you can do it locally. This is the timeline we presented in 2015, and one of the changes we have made during this year is that we have taken 5 years out of the end. So in 2015 we had autonomous ocean-going cargo vessels in 2035, but now we see that it will be happening faster, and it may be even before 2025 already, because there's a lot of different projects ongoing globally in this field, and a lot of different developments as well. So it's speeding it up quite a lot. Earlier today we saw the kind of the autonomy levels for cars in the presentation. Maritime is a bit more difficult because these haven't been confirmed anywhere. So currently there's still about 7 different interpretations of these levels, but this is our own interpretation, and this is what we're trying to get everyone else to agree with. So vessels today are more or less in level 2 systems, and we are working on solutions from level 3 forward. And we have currently demonstrated level 4 systems already as well. But it's a long road, and it depends on how you look at the vessel, because car is quite simple, where you have one person in a car, he's driving it and most likely owning it. But in a ship, someone is owning it, someone else is driving it, and someone else is most likely owning also the equipment and taking care of those. So it's a bit more complex thing to get it into one map, but these are estimation. And as you can see on level 7, there is still question marks who will then be responsible if we go into full autonomy. And autonomous ships are not for all types of ships. So don't worry if you go on a Caribbean cruise lines, it's not meant to be autonomous in near time. It's still, the purpose is more on these vessels on the right-hand side. So what we are doing is we have a lot of technology that is enabling or needed for autonomous ships, and we are developing those technologies. And we are implementing those technologies now on all types of ships. But then the further we go into autonomous operations, then there is currently less and less amount of vessels they can be used. For example, just because of risks, LNG carriers are not suitable for remote operation or unmanned operation, or an autonomous operation. But then bulkers are they're not so risky in that sense, because what they carry is usually goods which could be taken out in different manner, and it's not so hazardous if they collide with someone. It's of course hazardous, but not so hazardous. But the main areas where we think the moving will be, and the first vessels will be road ferries, and then tugs and maybe supply vessels, which are basically just transporting goods from shoreside to oil rigs. So they are like trucks of the seas in that sense. So vessels which are doing all the time same kind of operations, repetitive tasks. So basically same principle as in factory automation, where you replace robots with repetitive tasks. So I think we are heading the same way as well. Then first, this is the kind of the first vessel which is currently going out, which is more or less autonomous. So this is a ferry in Norway, a fully battery-operated ferry, and it is equipped with something we call auto-crossing system. So the system on board takes care of everything for the voyage. Only thing what the captain has to do is to close the ramp and open the ramp. Everything else is automatic. And then if something happens, the captain will intervene, so he's always on board and has to stay awake for the voyage as well. And then this is our world's first remotely operated vessel. So in principle, we have demonstrated what is our aim in 2020. We demonstrated this in February this year in Copenhagen. So this is a harbor dock from a company called Switzer in Denmark. And it's a brand new one. We fitted all the systems on board this vessel in the shipyard, and then we operated it, or have been operating it during this year remotely already. And it is the world's first classified remote operated tugboat as well. And here's the operation center for that, so the control center. And I think now is good time to have first UX slide as well. We've gone already 14 slides without talking about that aspect so far. So for remote control, and especially for this project, it was one-off solution. And the customer wanted to utilize remote controls as fast as possible. So we knew that the only way to make an impression on the customer was the remote control center, because that's basically the only new thing he will get. Vessel will be the same, it will look like the same. There may be some sensors, but they are not so unique. So we put a lot of effort on the operation center itself. So we brought from Rolls-Royce, we bought our own maritime expertise, we bought our UX people, our industrial designers, but then we also partnered up with two different companies. A company called Northern Works, who mainly works in automotive industry, and we gave them the task to look at the industrial design and the space itself, to design the space, floor, lights, and then looking at the ergonomics of the chair, the surfaces, how they feel in different conditions, materials we chose, and also manufacturing methods, because we use rapid prototyping quite a lot in this project. And then from user experience design point of view, we brought in a company called Idean, also a Finnish company, and their main task was the task analysis work, usability, and the total system usability evaluations, and also give feedback for the user interfaces, and also look after the adjustability of the operating center for different crew members working in the space. And then going the UX process a bit more. So this is quite of our standard way of working if we are working on a customer-specific solution. So we start off always with task analysis work. We do make full task analysis reports, but we also want to make a video out of it. So it's also training material for our new people, and we can reuse that material internally as well. And it's also crucial information for future use when we go into autonomous operations, because then we have gathered information from vessel-specific operations and what they do on board and what different crew members do. And also we always try to gather the silent information, which is kind of the traditions they have and something they are just used to do, but don't tell that they actually do it like that. Then after that, we do also, in this case, we did also extreme conditions analysis work. So we went out during nighttime and during storm, because the conditions change a lot during day and during the year. And then we rounded off with gap analysis work, and where we looked at which are the gaps we haven't filled, and then filled those as well. Then after we've done the kind of analysis bit, then we went into the mock-up phase and just made a quick prototype using plywood for the chair, and carried out a lot of user interviews and ergonomic studies with the captains themselves, so they had a lot of effect on where are all the handles, where are the screens, how low they are, what is the distance between the chair and the handrests, in which kind of angle the handrests are, and so on. And then that was the end result, how it came out. And this is now fulfilling these customers, all of their captains' needs and wishes. And then, of course, just in the end, we run also the final validation evaluations. So during the operations, when they're running the vessel remotely, we gather feedback from them if it's working like they thought it would be, or do they want to make some changes in the system. And then we can make some adaptations if needed. So that was in this case, but if we go back in time and look at the UX process creation within Rolls-Royce and how kind of UX has been in our company, we have started with user-centric design already in the 80s for human-machine interfaces. So a lot of our for example, the control levers have been first user evaluation and the studies, how they use them and their ergonomics. So that part has been always there, but it's been more focusing on individual levers and maybe some other functions, but quite focused research work. But then in 2012, we participated in a program called WUC, which is user experience and usability of complex systems. And there was a lot of other different Finnish companies involved in this program as well. There was Kone, Fastens, MacGregor. It was Kone Cranes, not MacGregor. But a lot of companies involved, and a lot of research institutes as well. And I think you can get the material afterwards, and there's the link to the final report of that program if you're interested. But there we studied different aspects of UX design. We looked at it from what it means for management. If you want to get it like Kone has, they have something called people flow, so it's already in their strategies. So what it means if you want to get UX into your strategy, how you should adopt it and what kind of steps you need to take. Then we looked at that from innovation side, what it means for innovation creation and other aspects as well. And I think the innovation creation was the main thing for us, because we created a new kind of tool to innovate, where UX is very central throughout the process itself. It is branded as InnoLeap, and we did it together with Finnish Technical Research Institute, VTT. It has 7 different modules, so and I can go through the modules themselves one by one. So we start off with trend and insights, so it's basically your normal background studies, looking at the technologies you need to address, or you could address, looking at the future interaction trends, social trends, other mega trends that could be coming into place, and then the theoretical ideas you may have, and then put all of these ideas together without any boundaries. And then as a summary on outcome of that, there is a summary of the most important trends and theories that are related to your product that you're innovating around. And in our case, in this, we used autonomous ships and the whole concept of autonomous operations as the innovation platform. Then the second one, and as equally important background study phase, is the analysis of user activities. So to dive in deeply to the users themselves and analyze what they do, how they do it, and why they do it. And we also created a tool for ourselves where we can go from setting the research questions such that we don't have to go and ask what you're doing, but we can ask instead, why are you doing it? Which is, in our opinion at least, more powerful question, because then you can get into the root of the actions they're carrying out. As part of this is core task analysis and joint cognitive analysis. So we have created different kind of maps, how the people on board interact with machines, how they interact with each other, and then where are the gaps in all of these interactions. And as an outcome of this, you get quite good understanding of what's actually happening in that domain where you are innovating around. Then third module is the drafting of the concepts themselves. So then we go into low fidelity sketching, have a lot of mock-ups and ideas, and just start sketching out different ideas and concepts. And in fourth module is the concept evaluations. This could be looked also as a marketing tool. It certainly is that for us, because when we take our best ideas and concepts and go to our customers, then they get engaged into those concepts as well. And what we see now is that all of those customers we engage during this process are coming back to us and asking where's the development currently ongoing. So they are keen to see the end results where they were affecting on the results and doing. And then we carried out a lot of focus group interviews, so both internally and externally, but it is important to get the external feedback. And I think it was one of the shipping company owners who said that it's this kind of collaborative work is more powerful than any kind of marketing work you can do. You engage the end users, engage their management and people into this collaboration. Then fifth module is creating the final concepts. So based on the feedback we got from customers, then we take out the best ones. We had different kind of criterias. We evaluated each idea that if it's potential or not. If it's not potential, would it be in 5 years' time or in 10 years' time? So then we put it into different kind of boxes, and then created high-resolution images and concepts out of these, and visualized them in the sixth module. So this one is the high-resolution one. So we made, in this case, we made 3D animated concept videos to support and highlight how the ideas are and what kind of they are. And it's much easier to tell your story to whomever when you have good quality graphics to support yourself. And then you can reuse these anywhere after your innovation session. So they're in that sense also providing you further information for marketing as well. And then seventh module is the release to public. If that is something you want to do, that's something we did. And one of the reasons that we wanted to push it to as much as possible into different medias, because we use it also as a crowdsourcing tool. So we monitor different kinds of discussion forums, and those are our R&D platforms as well. Because there are maybe 5 or 6 discussion forums related to maritime where you have a lot of sea-going people participating, and the feedback they have provided for these, we have taken those back into our development work as well. So we are using it as crowdsourcing. And there's just some of the articles which have been written since we released this in March 15. But I can just show you briefly, this is the trailer version of the concept video, and if you want to see the whole concept, it's in YouTube and it's about 7 minutes long. But this is just highlighting some of the ideas we had. There's only dramatic music in the background, so you don't have to worry. No one's talking about anything. But altogether, this video, in 7 minutes, we have about 150 different ideas and concepts we have evaluated. Some of them are hidden, some of them are visual, but it's a lot of different things. And when we made these videos, we had the choice of either we write a white paper out of all of these ideas, or we make the video. And we chose the video as a better tool to convey the ideas we have. So what I'm trying to tell is that the storytelling is really powerful tool to get your concepts and ideas out. And especially when we're talking about UX development, their storytelling and feelings are in the center of everything. So you can set the mood by sound, you can tell it by visuals, and then you can add other layers as well if you want, but it's really, really powerful. And one of the good things, and in the beginning we wouldn't, if someone would have told us that one of the biggest shipping companies in the world would change their strategy based on our video, we would have laughed them out. But actually there's now 2 of those already. So what they've done, that their presidents have seen the video, have shown it to their strategy board and said that this is our future. So it's been really effective and powerful in that manner. And this was created by using the InnoLeap UX innovation method. Then a bit about working towards autonomy, so where we are today and what we are doing today in this field. So as I told you earlier, we have this one remote-controlled vessel, but the UX challenge on a remotely controlled vessel is that the operators are always expecting to have the same that they have on board. And so you're stuck with current ways of controlling. And you can do some small things. Here's as a comparison, on the left-hand side you have our remote operating center, and on the right-hand side you have actual bridge of a tugboat. So in principle you have everything more or less the same systems there, same size of equipment and so on. So all of the equipment you're bringing to land still have the same design principles as they have on board. So they have to be robust enough when it's high seas, when it's going from side to side, and so on. So it's not bringing anything new in that sense. And then there is the challenge of senses. Because, for example, on a tugboat scale of vessel, which is rather small, everything is based on the operator's senses. They drive it from their backbone, so they don't look at any screens or anything, but it's just gut feeling. And when you take out the movements of the vessel and the sounds, then it becomes the same thing as driving blindly with your own car, when you don't feel anything. So it is a challenging task. But we try to do it by providing the vision, to some extent also the motion, but we don't want to bring in the motion sickness into play. But what we found out in our studies is that the sound is more or less the most important bit. And that's why we have sounds coming outside of the vessel into our operating center, so you can always hear what the captain would hear if he would be on board. Then the more important bit is the autonomous vessel, and the more interesting bit, because that then needs new ways of operating and new ways of providing the user experience. Because for an autonomous ship, it is most of the time going on its own, and it's no one's controlling. Automation systems are controlling, and the human is only monitoring it. So always when an intervention is needed, it's an ad hoc experience. So it's the same thing as you would be woken up in the middle of the night and someone tells you drive your car instantly. So that's kind of one of the challenges how you can address this situation where you are taken from comfort of an office into the middle of the high seas, middle of the storm where all the systems are not working. So you have milliseconds of time to adapt to that situation. And we are currently studying what are the kind of senses you need to have and what kind of information you need and what are the things we need to consider in that case so that you are fully alert and you can get on top of that situation as fast as possible. Then another challenge is that we are moving in some vessel types, from exciting to boring. Currently, tugboats, really exciting work. There's a lot of things happening all the time. But when we start to do that autonomously, then it gets a bit more boring when you're just monitoring things. It becomes like a paper mill. You just look at paper going all the time, and it's repetitive things. So that's the challenge, how you can address the boredom. But of course, then some vessels already have that today, long ocean-going ships where you're going from, say, Japan to US. There's not much happening at the bridge at all times. You're just sitting there and waiting to get to the other side, and it's on autopilot all the time. But that's also a thing we need to address. Then the new ways of controlling which we have defined. We have defined 3 different levels actually, and not yet ways of controlling. In the early stages, we already decided that we don't want to replicate the old ones in any of these. So we don't want to take the existing systems and use those for autonomous ships, because it wouldn't make any sense that you have 1/2 meter joysticks on an office room. Because 99% chance is that office room won't start going from side to side. So the levels of control we defined was melee, tactical, and strategic. Melee control is near real-time control, where control actions happen based on seconds and milliseconds delay. And then second level is tactical control, where control actions are based on minutes and seconds. So they give, for example, new commands, what to do next, and so on. And strategic control is based on days and hours. So that is during a long voyage, if you need to do, for example, port change, go from Japan to China instead, that kind of orders. And how you then convey those orders throughout the whole chain so that the ship actually does that as well. And then we have defined some of the benchmarks for these different ways. So for strategic, we are looking at board games and military games. For tactical control, we are looking at air traffic control as benchmark and automatic trains. And for melee control, we are looking at different kind of simulations and drone controls and near real-time control systems where you don't see the object you're controlling, but you have to do actions quickly. Then main human factors challenges we have identified. In this list we have 7, but you can read it from our research paper. There's a lot more insights in that. But one of the most important thing is the ship senses. As today, a lot of the seamanship is based on senses and sensing how things work. If a machine fails, the chief engineer knows it by walking into the engine room. The same way as we know that our car brakes have failed, we can hear it, we can sense it when we are driving our car. Same in ships, and same in the equipment over there. So how you can convey that kind of sense of that human sense into automation system. And same also applies for controlling the vessel, how you can control when everything is based on kind of gut feeling, how you control in challenging situations, how you can get that. Then second one is the implicit understanding of the intention of other vessels. Today, when you're on board, you get quite good understanding what the other vessels may do in different situations. But when you're remotely monitoring that from 2,000 miles away and you only see dots on a map, it's much more difficult then to get an understanding what it might do and where it might go. Communication, local knowledge and language. There are a lot of different things that happen around the world just because of geography. For example, once a month in Brazil at 2 o'clock all the satellites go down because of sunstorm. And these kind of things are the things you need to know in all around the world, in each different areas of the world. And that's the information that the current seamen have when they're operating in those areas. They know exactly at 2 o'clock, okay, I'm not relying on satellites anymore, I'm relying on something else. But then when we have remote operated vessel captain for the first time going into Brazil, it will be a mayhem when the systems go down, if he doesn't know that they tend to go down. Then boredom and vigilance, that's of course, I think, one of the challenges for autonomous operations globally. How do we tackle that? And we are trying to build our systems in such a manner that each day would be like a new day operating it and providing new feelings and new senses for the operators. And then it's clearly, of course, important to maintain the situational awareness at all times. Even though you're not on board, you're remotely monitoring it so that you know what's happening. And then the seventh one is the inhumanness and the image issues. For example, safety and rescue missions, how an autonomous ship can help if a passenger ship has collided with something else. Or if there is a decision to be made if our tanker collides with a passenger ship or goes to the side of a hotel, for example. So there are these kind of image issues which will also affect. And a lot of these questions will be solved in vessel-specific types, so there is no one clear way to solve these, but it's a combination of different ways. And based on these challenges, we have set our WUC goals for remote and autonomous operations. There's three different UX goals. First one is ambitious. So, and to support ambitious, we have put in brave, inspiring, visionary, and smart. So we want our systems to be safer than they are today, utilizing technologies and design patterns that work and have a purpose. So not just that they look beautiful and good, but they also have to have a purpose for being there. Second is alive. So everything should be, in the end, still personal, natural, intuitive to use, evolving, fusing, flexible, emphatic, and ambient. And it's an interaction of machine and human, and the joint cognitive science behind that is complex. But we want it to be as smooth as possible, and the collaboration to be as natural as it could be, so that the operator never has this feeling that this machine is taking over my job, but he's on top, and it's natural the way things flow. And the last one is essential, so safe, efficient, focused, optimized, and relevant, giving the user confidence to make right decisions at the right time, and empowering them with the relevant information. So systems today, they have tons and tons of information, but we only bring to their use the information they need at different times, and then everything else is on the sidelines. You can take it up if you want, but it's not at your sites at all times. Then what we are currently doing and working on, and the research works, we're working on the different novel ways of controlling the vessel. And I just put the gaming controllers there because there was just a recent announcement that US Navy has gone to Xbox controls, so that could be one way. It is one of the most easiest way to learn new control methods. I would say if you take 10 candidates from maritime school today, at least 9 of them has played either PlayStation or Xbox. So to learn them where the buttons are is fast. Just give those buttons a meaning and you can go. Instead of teaching them bridge system with 5 buttons which each do different things, and then screens which do different things. Most likely you will get better results out of the Xbox controller than designing something new. Then we are working quite a lot with gaming industry as well, because we see that the user interfaces in future will be based more of principles from game industry than industries themselves. Because gaming industry, they will either live or die based on user experience. If the games don't work or if it's too complex, people won't play them. So they are used to making things usable, intuitive, and simple. And then one of the key things for going forward is addressing the 1% of time chaos. So in a ship, normally 99% of time everything's okay, but then there's that 1% when everything goes into full chaos mode. and that is when alarms are raised. First you get one alarm, which is then followed by 10 different alarms, and then everything's already in chaos after that. No one knows what was the actual first alarm, and people start screaming or something. And that's what we're working on. So we're working on new different alarm systems so that they wouldn't be based anymore on individual alarms, but more on consequences on what should happen and what you should do. Then, as mentioned before, one of the tricky things is that how you can prepare yourself for a situation where you need to take over the autonomous vessel control. So we're looking at the psychology and UX of designing systems that are not meant to be controlled by human, and what if they need to be if intervention is needed, what should be done then? So these two aspects are highly critical for us. We're looking at what sensors you need, what information you need, and what kind of mood settings do you need. It's a different thing if you go on a ferry, which is just needing your decision on whether to go right or left, than a tanker that needs to make a critical decision on where to hit. So you need to be in a different mood set to make that decision within seconds. So these are the areas we're researching currently, and hopefully we can provide some inputs to this in future. I think we had this slogan in the morning speeches as well, but that's our ending slide. Any questions?